Hey, 5.5, solving equations by graphing. So today we're going to kind of go into another way of solving these types of equations, the ones you've seen in the past. Done talking? Okay. You have a single variable. We're going to solve that by graphing. So, okay, go ahead and follow the instructions there in Exploration 1. Do your best. This is on page 152 of your student journal. Work together. And so those of you that are struggling to figure this out, make this side equal to y and this side equal to y. So write two different equations. Y equals this and y equals this. Start by doing that and then graph both those equations. All right, so you have two equations. You have y equals 2x minus 1. You have y equals negative 1/2 x plus 4. Okay? And we graph them up. Negative 1. We rise 2. We run 1. So up 2 over 1. Okay. Continue that pattern. Get that dot as well. And we've got it. I'm going to call that y sub 1, my first y equation. All right, and the next one we got negative 1/2 x plus 4. So we go up to 4. We go down 1 and over 2. Down 1 and over 2. All right, continue the pattern that way and graph it up. And where those two lines cross is a solution to this. In order pair 2, 3. Now, what are we solving for, x or y? If I just gave you this equation, 2x minus 1 equals negative 1/2 x plus 4, what are we solving for, x or y? X. So which value here do I want, x or y? I want x. X equals 2. Now you could obviously check that by plugging it in. You could also go through and solve it like we did back in chapter 1, but hey, it works out, right? Okay. The graphical method works there. Okay? It works because each system or each set has to be equal to each other. All right. You checked it and it didn't work? 2 times 2 minus 1. 4 minus 1 is 3. Negative 1/2 times 2 is negative 1 plus 4 is 3. Okay? All right. Hey, I want you to go ahead and use an algebraic method. Use an algebraic method to solve this one. In other words, get the variable by itself. Do the same thing on this one. Get the variable by itself. All right, just like we did back in chapter 1. The goal is to collect the variables on the same side, so I am going to bring this 1/4 over by adding 1/4 to both sides. 1/4 x. That gives me 3/4 x plus 4 equals 1. I can get rid of the fraction by multiplying everything by 4. Multiply this side by 4 and that side. That gives me 3 times 4, or 4 times 3 divided by 4. The 4 is just canceled there, so I'm left with 3x. 4 times 4 is 16, and 4 times 1 is 4. Subtract 16. 3x equals 12, negative 12, and divide by 3. X is negative 4. Okay? X equals negative 4. Yeah. To get rid of the denominator. Okay. Could have moved the 4 first. So like on this one, when you go through and do it, subtract your 1/3 x from both sides. You end up with 1/3 x plus 4 is equal to 3. I could move the 4 first, maybe easier, and then get rid of that 1/3. So from this point, you multiply by the denominator of 3. You get 3 times 1 divided by 3, or x, equals, and then 3 times negative 1, negative 3. Okay? Yeah, everyone needs a graphing calculator, please. I'm going to give you steps to solve these using a graphing calculator and to graph them on a graphing calculator. My suggestion to you, because I won't tell you how to do this on your test or exam, I need you to write down your notes. So in your notes, write down the steps. First thing, if you're going to graph something on a graphing calculator and it's not your own graphing calculator, or you just get lost, you don't know what to do, then my suggestion to you is to start by clearing the memory. Clearing the memory, you push second plus, that will be the memory key. So if you look at your calculator display, second is like your shift key, and then plus, right above it you have mem. Okay, that gives you access to the memory, so second plus, it says memory. You want to select number 7, which says reset. So these two, I guess, give you mem. And then 1, once you hit reset, so option 7, and then 1 is all RAM. And then 2, which is reset. And then it gives you your display. All right. Most of you have that memorized from maybe doing it another year. So second plus 7, 1, 2. All right. From there, if you want to graph, when you are graphing, you are using the top row of keys to manipulate that graph and enter. So you're going to look at that top row, you're going to select the y equals key. When you push the y equals key, it gives you a bunch of places to put in equations. Y sub 1, y sub 2, this just means the first, the second, the third, the fourth equation, the fifth equation, and so on. So what I want to do is I'm going to check to make sure that this work is right, or I'm going to solve it graphically. I am going to call that y sub 1. So in other words, that equation is y equals 1/2 x plus 4. Okay, I know. I'll get back to it. And this equation is y sub 2, and that's y equals negative 1/4 x plus 1. So once again, that's a 2 and that's a 1. Okay, so after you get to your y equals menu, the next step is to enter your equations. Okay, so in your y equals, you got y sub 1 is 1/2 x. Now the sticking point, students are like, how do you do a fraction? How do you do a fraction? You just do 1. This is 1 divided by 2. Just push 1 divided by 2. You could, but you won't always have a perfect. Okay? So 1 divided by 2. Okay? And then the x key you are going to use is this x right here. So this one right here, you're going to push, that gives you x. And then plus 4. And then the next equation was negative 1/4 x plus 1. So the negative key, again, you have to use this negative down here. So negative 1/4 x, and it's plus 1. And then you push graph. When I push graph, you should see both lines up here. All right, so if you've got your steps there, that's it. That graphs your lines. The next step is to calculate the intersection. I'm going to calculate the intersection. Well, I have to use that top row. Which button will calculate? Yeah, Logan?
Well, I was going to say that I graphed mine, it looks different.
Okay, that if you graphed yours and it looks different, then check your equation. Okay? So, which button do I use to calculate? Second trace. Okay? So second trace says calc. Okay? Oops. Let me try that again. Second trace is calc. And then I am selecting which one to get the point of intersection. Option 5, intersect. Okay, and then it starts asking you questions. It says first curve. Well, I know these are straight lines, but usually in algebra, most of your graphs are going to be curved. Okay, first curve, as long as you have two equations, only two equations in there, really, you just hit enter. It's saying, hey, first curve, do you want it to be this one? The 1/2 x plus 4, and you hit enter, and that means yes. Second curve, do you want it to be the negative 1/4 x plus 1? Yep, we do. We hit enter. And then it says guess, and the reason it says guess is because as you progress in math, you're going to have other graphs where you're going to have multiple lines of intersection. In this one, we'd want that little cursor to go as close to that point of intersection as possible. So we just use our arrows, we hit enter, and it says -4, 2. X equals -4, y equals 2. So here you hit enter 3 times. Okay, and this gave us a solution of -4, 2. -4 for x and 2 for y. Well, we're only solving for x. So really the only value we're concerned about is -4, which is what we got. Now obviously it's much faster writing it out than graphing it. But the more you do these steps, the easier this becomes. And for those of you that struggled on solving equations earlier in the year, you could use a graphing calculator to solve any equation like that. Okay? If you had a messed up, weird equation like y, or not y,
As long as it has one variable.
2x plus 17 minus
over 201, how about?
3x
Over 201.
equals 4 times x minus 5
Over 201.
plus 1/2, just for fun, x. Okay, if you had that and you wanted to solve it, hey, this is y1. That's y2. Just put those in. So in fact, why don't you guys go ahead and solve that one?
Oh, I don't want to do that. Mr. McCoy, the calculator.
In a way, you could either reset your memory, or when you went back to your y equals, just overwrite or hit clear, and that'll clear that whole line. Just put your new line in.
There's only one line. What will I do?
Yeah, we get it in there and we hit graph and we see the little thing working up in the corner? Oh, the point of intersection isn't there. That's not good.
Hit zoom and then press 0.
Okay, what do you do?
And it'll make
Yeah, we zoom out. So which button is zoom?
F3.
The one that says zoom. You push zoom.
It's also labeled F3 in format.
And under zoom, we want to zoom out. So you select option 3 and then just hit enter. And you can zoom out as many times as you want. This time we only have to zoom out. We only have to zoom out once to see the point of intersection. But if you keep wanting to zoom out, you just keep hitting enter. Every time you hit enter, it zooms out further. It's like you're going higher in the sky, like getting a big aerial view. Okay? That's getting a little too far out, right? It's like really far out, man. Okay. Yeah.
I learned earlier today that don't hit enter while it's loading the line, or else your calculator might freeze.
Yeah, it might freeze. But then calculate. Second calc, or intersect, option 5, enter, 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 and point of intersection. X is 6.72. So in this equation, x equals, or approximately, 6.72. Did you? Did anyone else get 6.72? I could have entered it wrong.
I got 6.7.
May have entered it wrong. Double check your equations there, Sarah. Okay? Any questions on using the calci? Okay, we got one more piece that we're going to add today. I want you to take a look at page...
Drum roll.
Take a look at page 156 of your student journal, please. Page 156. Okay. We're going to start on number 8 here, and we're going to actually graph these by hand. Notice these are not linear. These are absolute values. Okay? And if you recall, when we deal with absolute values, you actually have to deal with a positive and a negative case. Okay? So as I'm setting this up, I am going to take this piece, take good notes here, that piece, and I am going to pull them out and have two different equations. I am going to have x minus 1 equals x plus 3. That's my positive. Both are positive. So this is a positive and this is a positive. And then I have to have a negative case. The negative case is I still have positive on this side. X minus 1 is still positive. But on this side, this chunk becomes negative. So you get negative, and I'm going to put parentheses, x plus 3. Those are the two cases. Yes, Sarah? I'm not sure. Are you talking about this? Yeah. This is always going to be, we're going to always keep that side positive. Okay, so positive equals a positive, and the positive equals a negative. Okay? Correct. Yep. Okay, so as I'm graphing this, I want you to graph these two equations. This is y sub 1, and this one's y sub 2. Graph that one on this graph, and then graph this one, y sub 1, and y sub 2 on this graph. Okay? Yeah. Y sub. Like it's in the subscript position. Y sub 1, y sub 2. Okay, or y1, y2, y1, y2. Okay, go ahead and graph them. I know, sorry. It's making it confusing. Hey, make sure to label your lines. It makes it a little easier later on. And what about these first set that you do? What's the solution over here?
No solution.
Yeah, no solution. They're parallel on that side, so here we get no solution. Hopefully we get a solution on the other side, because that one didn't give us any. Okay? Hi. This is, we just set this equal to y, and we set that one I drew on the other graph. Okay, and then this one I've got to distribute this. So that actually is y2 equals negative x minus 3. So I go down to negative 3, and then I go down 1 and run 1. Okay, and follow that pattern. Does this one intersect? Yes. What does x equal? Right there? Negative 1, negative 2. X is negative 1. So in this system right here, or excuse me, in this equation, x equals negative 1. That's the only value that will work. Okay? And I want you to graph I want you to put both those equations, those original ones, in your graphing calculator. And so before you do this, because you've already zoomed, you either have to reset your calculator. If you go to Zoom and select option 6, Zoom Standard, that'll bring you back to a normal viewing window. Okay? Or reset your calculator. Okay, how do we put absolute value symbols in?
You press math.
You push math. Push math. And then you go to number, NUM, arrow over 1, and select option 1. Then we put in our x minus 1. Okay, that's my first equation. That's this one. And you can do the same thing. Do it again. Watch. You go to math. You go to number. And then you select option 1. X plus 3. And hit graph. And you'll see, remember, absolute values are V shapes. So here's the one part of the graph that we did. We get our parallel lines. Here's the other side where we get our intersecting lines. Okay? All right. Now I got... Okay. Ladies and gentlemen, any questions? All right. Hey, that is what we've got going today. I want you to make sure that you calculate that point of intersection right there.
There are 2 rectangles.
How'd you do it? How do you calculate that point of intersection?
Second calc, 5. 5. You just press it 3 times. Wait until it's
-1. All right. Yeah. When you guys complete number 7, you have to use a graphing calculator for that, or come up with new grids. You're going to come up with 2 different answers on that one. Okay. So if you continue your lines up in your original display, I don't think it actually shows it crossing twice. You got to assume those lines continue, and you'll get 2 answers for that, 2 x values. It's going to hit 2 different times.